Hi, this is Steve, K8BZ. In this video I'm going to demonstrate how to use bandpass filters and notch filters in order to reduce, if not eliminate, QRM when trying to receive CW signals. We're going to talk about the bandpass filter. Most modern rigs have a few settings that are pre-saved in the transceivers for various filter settings. The particular radio I'm going to be demonstrating with is an ICOM 7600, and it has three pre-saved filter settings. They're specific for modes, but we're going to be talking about CW. The widest filter setting is 1.2 kilohertz. Now this bandpass filter will cause the receiver to receive any signal within that pass band. Now the pass band is going to extend 600 hertz below and above your dial frequency. So anything within that pass band will be received. So let's say, for example, when you tune a signal in, you're going to want the signal in the center of the pass band, and we're not going to discuss right now how exactly to do that. It's a fairly simple process, but you have the desired signal for your QSO tuned into the center of your pass band. And you're happily going along in your QSO, and then all of a sudden another signal comes in at the lower end of your pass band at a lower frequency. And now you've got some QRM. One option you can do, and it's a good idea on CW, a 1.2 kilohertz bandpass filter is quite a wide filter setting for CW. CW is a narrow signal. So you can switch to the next lower filter, which is a 500 hertz or half a kilohertz passband filter. Now the interfering signal is outside of the passband and you will no longer be able to hear it. Then if you continue in your contact and another interfering signal happens to come in above your frequency, and it's within your 500 kilohertz, your 500 hertz bandpass filter, which that one will receive 250 hertz above and below your dial frequency. You can switch to the other pre-saved filter, which is a 250 hertz bandpass filter. That's a very narrow filter, and it only receives 125 hertz above and below your dial frequency. So you have to tune very carefully because it's going to tune very sharply, and you could go past a signal very quickly. So you want to tune slowly if you're tuning using this filter, but that will eliminate the QRM above your signal also. Now we're going to demonstrate how these are used on the radio and show you how you can eliminate QRM simply by switching to a wider or narrower, in most cases a narrower, bandpass filter. We're going to demonstrate using the bandpass filter to eliminate QRM or to reduce QRM on CW. You'll find that over time your brain will automatically help you discriminate between signals, but that can be a very frustrating thing for a new CW operator to deal with, hearing several signals within the passband and trying to copy the desired signal and ignore the undesired signals. So this is where the bandpass filter will come in very handy. So we're going to listen on 40 meters. Right now we're using the widest filter. This is the 1.2 kilohertz filter. See how many CW signals you can hear in the passband. That loudest signal is someone calling CQ for a contest. It's the Florida QSO party. Just a moment ago there were several signals within the passband. He's getting a couple of callers now. Let's try to find a better example. There's a good example. There are at least three signals so far I've heard. That soft low pitch one, that high one, and the in-between pitch. Now we're going to switch to the next lower filter, the 500 hertz filter. I'm going to retune just a little bit. Still two signals. Let's say that's the desired one. Not the lowest pitched one, but the one that just stopped. Switch to the 500 or the 250 hertz filter. Again, this is going to tune very sharply, so we're going to tune this guy in. It's calling CQ Florida QSO Party. Now, we're not hearing any of that other interference right now. I'm going to switch back through the filters again, now that we've got this guy centered in the 250 hertz filter. There's the wide filter again. That loud signal is undesired. There's the 500 hertz filter. 500 hertz filter eliminated just about all of the QRM. There's the 250 hertz filter, and you don't hear any QRM on that. Now there's the station returning his call. We'll go back to the wide filter. Hear all the signals? 1.2 kilohertz filter, 500 hertz filter. And the 250 hertz filter. So just using the narrower filter and tuning carefully, we can eliminate just about all of the QRM that you hear on this filter setting with a 1.2 kilohertz filter.
The next filter we're going to talk about is known as the notch filter. Most modern transceivers include a notch filter in the transceiver, and it's a very useful filter for eliminating QRM in CW. It can also be used on single sideband, but a notch filter is a narrow filter, and sideband signal, usually you would use the bandpass filter to try to eliminate some QRM on sideband, but if you happen to get a CW signal near your sideband signal, a notch filter could be very effective in eliminating CW QRM. But at any rate, let's say we're having a CW QSO and we're using our 500 hertz bandpass filter, and another signal happens to show up near the upper end of our passband and causing QRM. Now we could switch to the 250 hertz filter and try to eliminate the QRM, or we could enable the notch filter. Now a notch filter is adjustable. What it does is it changes the shape of the passband and creates a deep notch within the passband that you can manually move around within the passband to specifically notch out a particular portion. To demonstrate that graphically, let's say we enable our notch filter, and you'll see the notch filter is shown in red, and you'll see a deep notch in the shape of the passband. As you tune the adjustment for the notch filter, you can move that notch around within the passband, and you will find that when you reach the point in the passband where the interfering signal is, you will notch it out. Obviously the name comes from the notch that it creates in the passband, and it will notch out the interfering signal. Now we're going to try to demonstrate using a notch filter to eliminate QRM also, so you can see how that can be used effectively when operating CW.
Now we're going to show how the notch filter can be used to eliminate an interfering signal. We moved up to 20 meters, so we'll turn up the AF gain. We hear a couple of signals here. Now we want to keep that higher pitch signal, the desired or the lower pitched one. I'm sorry. There's a higher pitch signal in there that is calling also. We'll wait till he transmits. There he is. Now we're going to enable the notch filter. We can still hear them both. Now I have to adjust the notch to notch out that undesired signal. There. Hear how he disappeared? Now that guy we can still hear. the notch filter back and forth across that undesired signal, and you'll hear how he disappears. There he is. I'm going to tune back. We've got him notched out. There's our desired station. If I move the notch, we'll hear the other station again as soon as he transmits. There he is. Notch him out. Move the notch. So we have the interfering signal notched out. He's not bothering us. And we can copy the desired station, no problem at all. So that's how you use the notch filter.
We hope this has been helpful and allowing you to better enjoy operating CW. And we hope to see you on the band soon. 7-3.